Good morning, my dear students. Welcome back to plus 2 physics class. In the last class, we started our chapter electromagnetic waves. Okay, electromagnetic waves. In that session, we just started what is electromagnetic waves and what are the nature of electromagnetic waves and what is the properties of electromagnetic wave. Okay, that will be discussed in the last session. Okay, today we are continuing this chapter. Today we are going to discuss the topic electromagnetic spectrum. Okay, electromagnetic spectrum. Okay, listen. The electromagnetic spectrum is an arrangement of electromagnetic radiations. Okay, it is an arrangement of electromagnetic radiations according to their wavelength or frequency. Okay, according to their wavelength or frequency. What is the electromagnetic spectrum? Electromagnetic spectrum is an arrangement of electromagnetic radiations. Okay, radiations according to their wavelength and frequency. What are the electromagnetic radiations? There are 7 electromagnetic radiations. First one is radio waves. Okay, radio waves, microwaves, infrared, visible light, ultraviolet, X-ray, gamma ray. Okay, what are the electromagnetic radiations? Radio wave, microwaves, infrared, visible light, ultraviolet, X-ray, gamma ray. Okay, these are the electromagnetic radiation. Okay, then the arrangement or an arrangement of these electromagnetic radiations according to their wavelength or frequency. Okay, that is it arranged in the increasing order of frequency or decreasing order of wavelength. Okay, that is the electromagnetic wave. Or in electromagnetic spectrum, the sum of the waves in the increasing order of wavelength. Okay, sum of the wave in increasing order of the frequency. Okay, increasing order of the frequency or decreasing order of the wavelength. Okay, here the increasing order of the wavelength, frequency means first we write radio waves, microwave, infrared, visible light, ultraviolet, X-ray, gamma ray. This is the increasing order of frequency. Okay, in this spectrum, in this electromagnetic spectrum, the arrangement is like that. That is the increasing order of frequency. Okay, increasing order of frequency. At the same time, the wavelength is decreasing. Okay, or the arrangement of these electromagnetic radiations according to their increasing order of frequency or decreasing order of wavelength. Okay, wavelength, decreasing order of wavelength. Okay, this is the structure of electromagnetic spectrum. Okay, electromagnetic spectrum. What is electromagnetic spectrum? It is an arrangement of electromagnetic radiations. Okay, electromagnetic radiations according to their frequency or wavelength. Clear? Okay, listen. In this spectrum, what is the arrangement? Listen, from downward to upward. This is the increasing order of frequency. Okay, this is the increasing order of frequency. That is in the lower section or in the lower part, it is radio wave. That is the frequency is low. Okay, and the frequency is greater in the case of what? Microwaves. Okay, microwaves according to compared to or with respect to what? Radio wave. Okay, that is, this is the increasing order of frequency. Okay, in this spectrum, the radio waves, not radio waves, electromagnetic waves are arranged in the increasing order of frequency. Okay, increasing order of frequency. And in the case of wavelength, it is what? Decreasing order of wavelength from downward to upward. Okay, what is that? Decreasing order of wavelength. Okay, decreasing order of wavelength. Then next we are going to discuss the characteristics of these electromagnetic radiations. Okay, what are the characteristics of electromagnetic radiations, and what are the uses of electromagnetic radiations? Okay, that we'll discuss next. Okay. Next we are going to discuss what are the characteristics and uses of electromagnetic radiations. Okay, or the detailed study of electromagnetic radiations. Okay, there are 7 electromagnetic radiations. What are they? Radio waves, microwaves, infrared, visible light, ultraviolet, X-ray, gamma ray. Okay, gamma ray. These are the electromagnetic radiations. Okay, next we are going to study these electromagnetic radiations. What are the characteristics of these electromagnetic radiations, how to produce these electromagnetic radiations, and what are the uses of electromagnetic radiations? That we'll discuss the next topic. Okay, in that the first electromagnetic radiation is radio waves. Okay, radio waves. The radio waves are produced by the accelerated motion of charges in conducting wires. Okay, the radio waves are produced by the accelerated motion. Okay, accelerated motion of charges in conducting wires. Okay, in conducting wires. And the radio waves are used in radios and televisions. Okay, televisions and other communication systems. Okay, that is, we are using these radio waves in radios, television and other communication systems. Okay, other communication systems. Clear? Okay, and they are generally in the frequency range from 500 kilohertz. Okay, from 500 kilohertz to 1000 megahertz. Okay, 1000 megahertz. The higher frequency, okay, the higher frequency up to 54 megahertz. Okay, higher frequency up to 54 megahertz are used for short wave bands. Okay, short wave bands, that is TV waves. Okay, television waves range from 54 megahertz to 890 megahertz. Okay, 890 megahertz. Okay, TV waves range from 54 megahertz to 890 megahertz. That is, higher frequencies up to 54 megahertz are used for short wave bands. Okay, short wave bands. In television waves range from 54 megahertz to 890 megahertz. Okay, 890 megahertz. Clear? And in the FM radios, okay, what is FM? FM means frequency modulated. Okay, frequency modulated. Okay, the frequency modulator or FM radio band extend from 88 megahertz to 108 megahertz. Okay, 88 megahertz to 108 megahertz. Okay, megahertz. And the cellular phones, okay, cellular phones use radio waves to transmit voice communication. Listen, the voice communication in the ultra high frequency band. Okay, ultra high frequency band means very high frequency range. Okay, that transmit, or this radio wave to transmit voice communication. Okay, voice communication in the ultra high frequency band. Okay, ultra high frequency band. Clear? Okay, these are the characteristics and uses and how to produce these radio waves. Clear? Okay, next we are going to discuss microwaves. Okay, microwaves. These microwaves are produced by special vacuum tubes. Okay, special vacuum tubes such as klystron, okay, klystron, magnetrons, okay, magnetrons or gun diodes, okay, gun diodes. Okay, that is microwaves. Okay, microwaves are produced by special vacuum tubes. Okay, special vacuum tubes such as klystron, magnetron, gun diodes. Okay, gun diodes. And these microwaves are used for the radar system. Okay, radar systems used in the aircraft navigation. Okay, radar. That is this microwave used in radar. Okay, and radar also provide the basis of the speed guns used in time fastballs, tennis serves, and automobiles. Okay, automobiles. Okay, that is this radar also provide the basis for the speed gun used to time fastball. You see for tennis serve, for practicing we using this speed gun. Okay, speed gun. And for tennis serves and automobiles, it is used in automobiles. And another use of this microwave is it is used in micro ovens. Micro ovens, we have what is micro ovens? Micro ovens is cooking appliance. Okay, it is a cooking appliance. Okay, how to work this? In such a ovens or in micro ovens, the frequency of the microwave is selected to match the resonant frequency. Okay, resonant frequency of water molecules. Okay, water molecules. So that the energy from the wave is transferred efficiently to the kinetic energy. Okay, that is that energy is changes into kinetic energy of the molecules. This is rise the temperature. Okay, that is the kinetic energy is increases, that time what will increase? The temperature will increase. That is, this rises the temperature of any food containing water. Okay, any food containing water. This is the simple working of this micro oven. Okay, and it is also used in satellite communication. Okay, satellite communication. Okay, these are the characteristics and uses of what? Microwaves. Okay, next electromagnetic radiation is infrared. Okay, infrared. Okay, these infrared waves are produced by hot bodies and molecules. Okay, these infrared waves are produced by hot bodies and molecules. Okay, and the infrared waves are referred to as heat waves. This is because the water molecules present in the most materials readily absorb. Okay, readily absorb infrared waves. Okay, there is many other molecules. For example, carbon dioxide, CO2, and NH3 also absorb infrared waves. Okay, also absorb infrared wave. And after absorption, okay, after absorption, their thermal motion increases. Okay, the thermal motion increases. That is, they heat up and heat their surroundings. Okay, and heat their surroundings. Okay, and infrared radiations plays an role in maintaining the earth warmth, okay, earth warmth or average temperature through the greenhouse effect, okay, greenhouse effect. What is that? Infrared radiations plays a role in maintaining the earth warmth or average temperature through the greenhouse effect, okay, through the greenhouse effect, okay. And incoming visible light is absorbed by the earth, okay, absorbed by the earth's surface and radiated as infrared radiations. Okay, this infrared radiations or this radiation is trapped by greenhouse gases such as carbon dioxide, water vapors, okay, and CFC, okay, CFC, clear. And the main use of this infrared is, one of the main use of infrared is infrared detectors, okay, infrared detectors are used in earth satellites, okay, earth satellites both for military purpose and to observe the growth of crops, okay. That is in infrared detector we are using this infrared waves. And some electronic devices, for example semiconductor, that is light emitting semiconductor, okay, light emitting semiconductor also emit what? Infrared, okay, infrared, and are widely used in the remote switches, okay, that is our remote control. For remote controlling we are using this infrared, that is the electronic device, that is in remote we are using infrared, okay. And video recordings and hi-fi system, okay, that is remote switches or remote control of household electronic systems such as TV, video recorders and hi-fi system, okay, hi-fi system. And other use of infrared waves are, it is used in secret signaling and burglar alarms, okay, secret signaling and burglar alarms, and it is used in the treatment dislocations, okay, used in the treatment of dislocation and paralysis, etc., okay, and used to take the photography of distant object, that is in night vision cameras, okay, in night vision cameras we are using infrared waves. And it is used in physiotherapy and used for determination of molecular structures, okay. These are the uses of infrared waves, okay, infrared, okay. And the next one is visible light, okay, visible light. It is a part of the spectrum that is detected by the human eye, okay. This visible ray or visible light, it is the part of the spectrum that is detected by the human eye, okay. It runs from about a wavelength range of about 700 nanometer to 400 nanometer, okay, 700 nanometer to 400 nanometer, okay, 700 nanometer to 400 nanometer. And in this spectrum, that is in the visible ray, arranged 7 colors, that is VIBGYO: violet, indigo, blue, green, yellow, orange, red. That is a visible spectrum, okay, that's also called visible spectrum. In that visible spectrum there are 7 colors arranged, that is VIBGYO: violet, indigo, blue, green, yellow, orange and red, okay. And the visible light emitted or reflected from object around us provide us information about the world. Our eye are sensitive to this range of wavelength, okay, this range of wavelength. And the different animals are sensitive to different range of wavelength. For example, in the case of snake, okay, snake can detect infrared waves. Okay, snake can detect infrared waves and the visible, okay, and the visible range of many insect extend well into the ultraviolet. Okay, ultraviolet. In the case of human, it is visible ray. Okay, that is in the range. The wavelength range is 700 nanometer to 400 nanometer. Clear? This is visible rays. Okay. Then the next one is ultraviolet rays. Okay, ultraviolet rays or UV rays. Okay, UV rays. This ultraviolet radiation is produced by special lamps and very hot bodies. Okay, special lamps and very hot bodies. That is, ultraviolet radiations is produced by special lamps and very hot bodies. The sun is an important source of ultraviolet. Okay, the sun is an important source of ultraviolet, but the most of it is absorbed in the ozone layer. Okay, in the atmosphere at an altitude of about 40 to 50 kilometer. Okay, 40 to 50 kilometer. Okay, that is, the sun is an important source of ultraviolet. It is very important. Listen, the sun is an important source of ultraviolet light, but the most of it's absorbed in the ozone layer. Okay, in the ozone layer in the atmosphere at an altitude of about 40 kilometer to 50 kilometer. Okay, 40 kilometer to 50 kilometer. And ultraviolet in large quantities has harmful effects on humans. Okay, it is exposure to UV radiations includes the production of more melanin, causing tanning of the skin. Okay, and ultraviolet radiations is absorbed by ordinary glasses or ordinary glass. Hence, one cannot get tanned or sunburned through the glass window. Okay, through the glass window. Okay, and welders. Okay, welders wear special glass goggles or face mask with a glass window to protect their eyes. Okay, protect their eyes from large amount of ultraviolet produced by welding arcs. Okay, and UV lamps are used to kill germs. Okay, one of the important use, that is UV lamps. Okay, UV lamps are used to kill germs in water purifier. Okay, in water purifier. And ozone layers in the atmosphere plays a protective role from this ultraviolet. Okay, and one of the important uses used in the manufacture of fluorescent tube. Okay, fluorescent tube or CFL, no? CFL. Okay, compact fluorescent lamp or fluorescent tube. Okay, that is, this ultraviolet rays used in the manufacture of fluorescent tube, and it is used to determination of age of written documents. Okay, written documents, the age of the written documents. Clear? And it is used in the detection of fingerprints. Okay, it is used in the detection of fingerprints, and it helps to produce vitamin D in our skin. It is very important use. Okay, what is that? It helps to produce vitamin D in our skin. Okay, in our skin. Clear? These are the ultraviolet rays. Is it okay? Okay, next we are going to discuss the next electromagnetic radiation, that is X-ray. It is very important. electromagnetic radiation, X-ray. Okay. The X-rays beyond the UV region of the electromagnetic spectrum lies in the X-rays region. Okay, this X-ray is first discovered by W. Röntgen. Okay, W. Röntgen discovered X-ray. Okay, and one of the common way to generate X-ray is to bombard a metal target by high energy electron. Okay, to bombard a metal target. Okay, a metal target by high energy electron. Okay, high energy electrons. And X-rays are used as diagnostic tool in the medicine. Okay, it is used in the diagnostic tools in medicine and as a treatment for certain form of a cancer. Okay, certain form of cancer. Okay, it is used as treatment for certain form of a cancer. Okay, because X-rays damage or destroy living tissues. Okay, why it is used for diagnostic tool in medicine and for treatment for certain form of cancer? Because X-rays damage or destroy living tissues and organisms. Okay, care must be taken to avoid unnecessary of overexposure. Okay, overexposure. And it is used to study the structure of atoms. Okay, structure of atoms, molecules, atom molecules and crystals. Okay, crystals. And another use of X-ray is used to detect cracks and holes inside a sheet of metal. Okay, the X-ray is used to detect cracks. Okay, cracks and holes inside a sheet of metal. Okay, sheet of metal, and it is used to detect hidden materials. Okay, hidden materials. Okay, this is X-ray. Okay, X-ray. And the last one is gamma ray. Okay, gamma ray. They lie in the upper frequency range. Okay, upper frequency range of the electromagnetic spectrum. Okay, that is in the case of gamma ray, the frequency is very high. The frequency range is very high. In the case of radio wave, the frequency range is very low. But in the case of gamma ray, it is very high. This high frequency radiation is produced in nuclear reactions and also emitted by radioactive nuclei. Okay, that is this gamma rays is produced in nuclear reactions and also emitted by radioactive nuclei. Okay, radioactive nuclei. And they are used in medicine to destroy cancer cell. Okay, they are used in medicine to destroy cancer cell, and it is used to study the structure of nuclei of atom. Okay, it is used to study the structure of nuclei of atom. Okay, and another use of gamma ray is it is used to sterilize surgical instruments. Okay, sterilize the surgical instrument, and it is used to detect the cracks in underground metal pipes. Okay, underground metal pipes. Okay, this is the electromagnetic spectrum. Okay, a small topic, that is the production and detection of electromagnetic waves. That is, here we discussing a small table. This is a table. In this table, given the electromagnetic radiations and the wavelength range and how to produce this electromagnetic radiations and how to detect this electromagnetic radiations. Okay, the first one, radio waves. Okay, radio waves. The range of the range of the wavelength of radio wave is less than 0.1 meter. Okay, less than 0.1 meter, and the production of radio wave is rapid acceleration and deceleration of electrons in a areals. Okay, this is the production method. Okay, production of radio wave. How? The rapid acceleration. Okay, rapid acceleration and deceleration of electrons in areals. Okay, and the detection is receivers aerials. Okay, receivers aerials. By using receivers aerials, we detect the radio waves. Okay, and the second one is microwaves. Microwaves wavelength range is 0.1 meter to 1 millimeter. Okay, 0.1 meter to 1 millimeter, and the production that already discussed, that is the klystron value or magnetron value. Valve, sorry, not value, valve. Okay, that is klystron tube or magnetron tube or valves. Okay, and the detection by using a point contact diodes. Okay, by using a point contact diodes, we detect the microwaves. Okay, and the next one is infrared. The infrared range is 1 millimeter to 700 nanometer. Okay, 700 nanometer. Okay, and its production is vibration of atoms and molecules. Due to the vibration of atoms and molecules, the infrared will produce. Okay, and the detection or detecting material is thermopiles, polometer, infrared photographic films. Okay, infrared photographic films. Okay, thermopiles, polometer, and infrared photographic films. And the next one is light, that is visible light or visible ray. The range of wavelength is 700 nanometer to 400 nanometer, and the production is electrons in atom emit light. Okay, electrons in an atom emits light when they move from one energy level to a lower energy level. Okay, a lower energy level. And the detection by using eye. Okay, by using eye and photocells, photographic films. Okay, and the next one is ultraviolet. Ultraviolet. The range of wavelength is 400 nanometer to 1 nanometer. Okay, 400 nanometer to 1 nanometer. And the production is inner shell. Okay, inner shell electrons in atom moving from one energy to a lower energy level. That is, in the case of an atom, we have the so many shells. Okay, the inner shell electrons. Okay, inner shell electrons in atoms moving from one energy level, that is higher level energy, to a lower level. Okay, and the detection by using photocell, photographic films. Okay, okay. Then next one is X-ray. 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 The range of wavelength is 1 nanometer to 10 raised to minus 3 nanometer. Okay, 10 raised to minus 3 nanometer. Okay, 10 raised to minus 3 nanometer. And X-ray tubes or inner shell electrons are produced what? This X-ray. And how to detect photographic films by using photographic films or Jigger tubes. Okay, Jigger tubes or ionization chamber. Okay, ionization chamber. Okay, then the last one is gamma rays. Gamma rays. The range of gamma ray is less than 10 raised to minus 3 nanometer. Okay, it is less than 10 raised to minus 3 nanometer, and it produced by using radioactive decay of the nucleus. Okay, due to the radioactive decay of the nucleus, the gamma rays produced. Okay, this is the production and detection of electromagnetic waves or radiations. Clear? Okay. Today we are discussed what electromagnetic spectrum. In that electromagnetic spectrum, we discussed electromagnetic radiation, that is 7 electromagnetic radiation, and what are its uses and how to produce these electromagnetic radiations and how to detect the electromagnetic radiations. I hope you all understand today's class. Thank you.